In this section, we will go through an introduction to AWS Cloud Computing. So what is cloud computing? Cloud computing is the on-demand delivery of compute power, database storage, applications, and other IT resources through a cloud services platform via the internet with pay-as-you-go pricing. Amazon AWS Cloud Services Platform provides rapid access to flexible and low-cost IT resources. So I did mention pay-as-you-go pricing. Well, this means that you pay only for what you use and when you use it. Let's now concentrate on applications and data centers. Applications and services are typically run on servers, which are comprised of CPU or the processor, RAM or memory, and storage, hard drive or SSD, where HDD is the legacy version and SSD or solid state drive is the new version of hard drives. Now, when I refer to applications, I'm referring to, let's say, email or web servers, like you're running your company's website on a web server, right? Databases that can serve the web server. Maybe you have a database of your clients, an FTP server, so file transfer protocol, and so on. So how can you run these services? You can either run in your company DC or data center, or you can literally rent the compute power and move it into the cloud. This is what it is. This is what cloud computing is. You literally rent what you need. You rent the compute, the storage power, and you pay as you go. Now, running services in AWS Cloud now. With cloud computing, you don't need to make large upfront investments in hardware and spend a lot of time provisioning the hardware. You provision exactly the right type and size of computing resources you need to power and run your services. You can run, let's say, one server or tens of thousands of servers in minutes as you need, almost instantly, and only pay for what you use. With AWS, you can stop guessing. Let's now go through a real-world example on how AWS can help you and your business. Imagine that you are the CEO of example.com corporation and you're running an online business. You have an online marketplace of thousands of products. In order to run the business, you are running the example.com website on your own infrastructure, so on your own servers in your data center. Currently, you have 3 servers running in your DC. So let's consider that 2 of them are web servers and the third one represents your database. Now it's November time and you are going to run a big campaign for Black Friday. Fortunately, this is a well-run campaign, so well done to the marketing department. Now, unfortunately, the web traffic hitting your servers, your web servers, has doubled, and you even registered peaks with 3 times more traffic than in an usual month of the year. Now, this has led to bad performance and really bad user experience that resulted in your company losing money. Now, next year, you decide to invest more in your data center and you buy 2 more servers, having now 4 web servers. Once you launch this year's Black Friday campaign, everything runs smoothly, excellent user experience, not even one complaint registered. Now, after this great and successful campaign, you realize that for the rest of the year, you don't need the additional 2 servers that you bought in January this year. And now this is a great example of bad investment. Let's consider now that you're running your business in AWS Cloud with Amazon EC2, so Elastic Compute Cloud, and for example one database using a DynamoDB. Now, once you launch the Black Friday campaign, you start experiencing traffic increase hitting your EC2 instances. This time, using AWS autoscaling technology, 2 more servers are deployed automatically by AWS and potentially even more 1 server, database server, so a DynamoDB. Now, excellent user experience for your clients, no upfront cost for you, and no initial investment. Once the Black Friday campaign is over, traffic returns to usual values and AWS automatically will shut down the servers that are no longer needed. Your AWS infrastructure, as you can see, is elastic and can automatically adapt to changes of your business. Your AWS infrastructure is scalable and it is able to scale up or down depending on your business and dynamic workloads that you may encounter at different times. And one last thing, with AWS you only pay as you go and pay as you and your business grows. And this is really fantastic. Let's now talk about different cloud computing models. There are three major types of cloud services available: IaaS or infrastructure as a service, PaaS or platform as a service, and SaaS, software as a service. The differences between them consist of, let's say, functionality and, very important, tasks, ownership and flexibility. So who's in charge with what, and what is your flexibility with your favorite choice, IaaS, PaaS or SaaS. Now let's have an example. So working on your own premises data center is the same as doing the maintenance of your personal car. Also, if you want a better, more powerful car, you then have to buy a new one, right? When you lease a car, then you choose the car that you want and drive it whenever and wherever you want, but now the car isn't yours. If you want a more powerful car, then just lease another one that suits your desire and needs. And this is the same as IaaS or infrastructure as a service. You can rent compute power, storage and other AWS services as you wish and run them when you want to. Now if you need to run a more powerful machine, you can upgrade it on the fly or just in a couple of minutes. Now when you get a taxi, you don't drive it yourself, but still you can go where you want. This is the same as platform as a service or PaaS. The last flavor is SaaS. So when you use SaaS, it's like traveling by bus. The bus has a pre-assigned route and can't be changed. You share the ride with other passengers. So this is just an application. You either choose to use it like it is or just leave it. Let's now talk about each of the versions or the options. So infrastructure as a service or IaaS contains the basic building blocks for cloud IT and typically provides access to networking features, computers, and data storage space. IaaS provides the highest level of flexibility and management control over the infrastructure. So you can literally do whatever you want with your virtual machines, and the best example here for IaaS is Amazon EC2, Elastic Compute Cloud. Now platform as a service or PaaS removes the need for your organization to manage the underlying infrastructure, so hardware and operating systems, and allows you to focus on the deployment and management of your applications. This helps you to become, let's say more efficient, as you don't need to worry about resource procurement, so basically also waiting for the equipment, capacity planning, software maintenance or patching. And the PaaS service in AWS is Lambda, and Lambda is really fantastic. We will talk more about it in the upcoming modules. The last one, software as a service or SaaS, provides you a complete product that is run and managed by the service provider. So with SaaS, you don't have to think about how the service is maintained or how the underlying infrastructure is managed. You only need to think about how you will use the app. Really, how you will use the app, what it does, and does it help you to run your business. So a common example of a SaaS application is a web-based email, for example Gmail. Now let's talk about cloud computing deployment models. So what are the possibilities? 3 cloud deployment models are currently available. The first one, on premises, is when you run everything in your own data center. So this is also called the private cloud. Hybrid is when you run some of your applications in your data center and some in the AWS public cloud. The last one is literally cloud. You run all your applications in AWS public cloud. So let's talk now about on-premises. Also known as private cloud, resources are deployed in your on-premises data center using virtualization and resource management tools. Now, when I say virtualization, let's think of VMware, also from Microsoft is the Hyper-V, and the open source version OpenStack. Private cloud option offers the ability to provide dedicated resources, not split between users or end customers. So only your applications will sit on the actual hardware. Well, as opposed to the public cloud where you have hardware, let's say a piece of hardware, a server, and on that specific server your applications are run, and maybe some others, some other let's say customers or end customers are run also. In the private cloud you have your own equipment and it is dedicated, only you run your applications there. You have full control over your infrastructure, and you are responsible, which is also important, for management and operating system patching, so applying fixes, or let's say patches to bug fixes. Now, hybrid. The hybrid deployment can be an intermediate step while you are on your way to fully migrating to the AWS cloud. A hybrid deployment is a way to connect infrastructure and applications between cloud-based resources and existing resources that are not located in the cloud. So simply put, it's just a mix between on-premises and cloud only. The most common method of hybrid deployment is between the cloud and your existing on-premises infrastructure in order to extend or grow your organization's infrastructure. So what most companies do, they first run in a hybrid, let's say, deployment model where at first they put, let's say, their testing infrastructure, DevOps or something like that in the cloud, and they stick to on-premises for the rest of their applications and services. The last option, the AWS cloud, the application is deployed in the cloud and all the components of the application are run in the cloud. Applications in the cloud have either been created in the cloud or have been migrated from an existing infrastructure to take advantage of the cloud benefits. Now, also in terms of terminology, migrating an application from on-premises to cloud is typically called lift and shift, and this refers to taking the application as it is without modifying it and running it on cloud native resources. Thank you, and see you in the next section.